Hello guys, I would like to welcome you all to our number pattern section. We're just going to be showing each other how we can do number patterns, right? Yes. So before we get to the creation, I just want to show you guys a few things, or we should just call it revision so that we can remind each other some stuff. When we have a pattern like this, 1, 3, 5, 7. Notice what is happening. For us to have 3, we added 2 to the previous term, which is T1. For us to have 5, we added 2 to 3, which is the previous term. For us to have 7, we added a 2 to 5. So in simple English, we would explain this as we are adding 2 to the previous term to get the next term. Okay? Okay. You guys did this in grade 9, I think, where you guys were saying we are adding 2 to each consecutive term to have the other term. Okay? But now in grade 10, you notice that you guys were introduced to a topic like this by your teacher. If you guys have covered the topic at school, Cn is equals to An plus B. Or your teacher could have used this formula. Cn is equals to A plus N minus 1 D. Okay? Both the formulas are fine. You guys just have to use the one your teacher introduced to you. But in this session, we are going to be using this formula. If there's anyone who would like us to use this formula as well, you guys can just let me know. Okay. So I want us to break down the formula so that you guys can understand what is happening. Let me change the color. Let's just use black. Okay. Tn is what we call the nth term, right? We call that the nth term, or the general term, right? So in this formula, Tn would be the value A. This is the common difference. Oh, before I forget, guys, because I said we're not going to be focusing on this formula, let me just erase it as well, because these definitions are not the same for this one, for this formula. So let me remove it so that you guys don't get confused. For those that would like us to use that formula, please just let me know. Okay? Okay. A is our common difference, and N is the term number, or position, the position of the number. Like here we have this one, we say we have T1, we have term number 2, we have term number 3, we have term number 4. So N is like T something, okay? It's the term number. And then B, we say that this is the constant. This is a constant value, which actually also explains what is happening with the pattern. Okay, now how do we find A? We find A, so we say A is equals to T2 minus T1, which is also equal to T3 minus T2, which is also equals to T4 minus T3 going forward. Okay, so this difference will be the same between all your terms. Okay, So for example, we had 1, 3, 5, and 7. So T2 would be 3 minus 1, which is equals to 5 minus 3, which is equals to 7 minus 5. Okay, this is to A. We're trying to find A. A is equals to 3 minus 1 equals to 5 minus 3 equals to 7 minus 5. Then we find that we're having a 2 here. The difference is a 2, 2. So you see that difference, it doesn't change because you guys are dealing with linear sequences or arithmetic sequences, okay? Or linear number patterns. Then we have B. We have B. How do we find B? So if you guys would like to copy the notes, please just pause the video a little bit. Okay. How we find B? Now that's the easiest. I said that B is a constant value. So to find B, we say B is equals to T1 minus the common difference. Common difference. Or if you guys, you can just, if you want, you can just say B is equals to term number 1 minus A, like that. Those are the formulas that you are going to be using. There is also another way, which I'll show you now, how we can find B. Remember, we have this pattern 1, 3, 5, 7. So now we want to find the general term or the nth term. We know that we have the formula T n is equals to an plus b. Do we have a? We can just find a by saying T2 minus T1, and then we can have 2 as our a, which we had calculated here, okay? And you can say this is 2n plus b. Tn is equals to 2n plus b. Now for you to find b, you can choose to substitute a, a term. Maybe let's take term number 2, which is 3. If you are taking term number 2, our 3 is going to be substituted where there is Tn, and because we know this is T2, we are going to substitute a 2 here. Now Tn will be 3 is equal to 2, then substitute the term number or the position of 3, which is 2 as well, plus b. 3, and then you have 2 multiplied by 2, this is 4. You take 4 to that other side. 3 minus 4 is equals to b. Now you find out that b is equals to negative 1. Okay, so that's how you can find b as well. If you want, you could just use the formula that I just told you, T1 minus a, which would be 1 minus 2, and you would have gotten a negative 1. Okay, alright, so that is all that I wanted to explain in terms of the formula, and yeah, just the introduction to the thing. Now we can now go to the question. Let's go to the question. Let me just try to erase this so that we can have space. Let me erase this part. Alright, we can start with our question. Consider the linear sequence 5, 8, 11, b, 17, and going forward. And now it says write down the value of b. So before you start looking at the questions, you can just find the little things to see how your pattern is going, right? 5, for us to have 8, we added a 3, right? Plus 3. For us to have 11, we added a 3 as well, plus 3. For us to have B, we're actually going to add a 3 to B. So now you say 11 plus 3, and then you can find that your B is 14. B is equals to 14. Then the next question, which is 1.1.2 says, determine the nth term of the sequence. And I told you guys, we are using this formula, Tn is equals to An plus B, right? You can choose to find your A and B out of the formula, like and separate, like finding A, like what we did here, or you can choose to find them. Either way, the way that you feel like you're comfortable with, use that one. Okay, let's rewrite our formula. Tn is equals to An plus B. Please excuse my handwriting. I'm actually sitting in a very uncomfortable space. And we know that for us to have A, we are going to say T2 minus T1, right? Which will be 8 minus 5, and then you can get 3. It will be T2 minus T1, which is 8 minus 3, and you get a 3. 8 minus 5, my bad. Then we can have 3n plus, for us to get b, we can choose to say b is equals to T1 minus a, which will be 5 minus 3. And then we will have a 2, meaning that our general term or our nth term will be 3n plus 2. Or we can use the method that I told you guys. You can choose to say Tn is equals to 3n plus b, and then you choose any value you want to substitute. Let's choose 17. 17 is equals to 3, and 17 is on term number 1, 2, 3, 4, 5. 17 is the 5th term, so we multiply 3 by 5 plus b. Then we are going to take 3 multiplied by 5, which is 15, to the other side. Now we have b as b is equals to 17 minus 15, and then we find that b is equals to 2. Then you can just go and say, therefore, Tn is equals to 3n plus 2. Okay? Then we have our next question, which says that calculate the value of the 15th term. Guys, I would like you to know that if they say something like this, just know that they are looking for Tn, the value. They're looking for Tn. So in your formula, you know that you are looking for this part here. You substitute, and your 15 is n. So 15 is n. So where there is n, you're going to substitute 15. Let's see if we have space. Okay. That's 1.1.3. 1.1.3. We're just going to say Tn. We take this Tn here. Tn is equals to 3n plus 2. Then we substitute. We're looking for Tn. We know that T15 is equals to 3 multiplied by 15 plus 2. Now T15, which is term number 15, this is how we read term number 15, is equals to 3 multiplied by 15, we have 45 plus 2, then we have 47. 47. So our term number 15 is equals to 47. And let's have 1.1.4, which is our last question. Which term in the sequence? Which term? If you see this, they are asking you for the term number. They're asking you for the term number or the position, meaning we are looking for n, okay? In the sequence is equal to 83. 83 is the value, meaning that where there is Tn, we are going to substitute 83, okay? We're going to substitute 83. So 1.1.4, 1.1.4, Tn is equals to 3n plus 2. And we know that here we have 83. 83 is equals to 3n plus 2. Note that we are looking for n. So you're not going to have anything to substitute here because that's what you're looking for. Yeah? And then we are going to group the like terms on their side, the like terms, the like terms on each side, okay? 83, 2 is a like term for 83, so we're going to have 83 minus 2. 83 minus 2 is equals to 3n. And then we have 81, which is equals to 3n. And then we divide both sides by 3. N is equals to 27. So 83 is on term 27 or term number 27 or T27, okay? So we just say therefore T27 is equals to 83. That's unnecessary though, but yeah. Thank you guys for watching this video, and I hope to see you next time as well.